Let's look at polynomial arithmetic and like terms. This will be the information found on the notebook pages 7 and 7a. I suggest you have downloaded the notebook PDF file so that you can follow along with the actual notes. First, let's talk about what exactly a polynomial and a polynomial expression are. A polynomial, as expressed in the PDF, is simply an expression that has constants, variables, and exponents. In this example, we'll use the polynomial 5xy squared minus 3x plus 5y minus 3. To start off with, let's find all of the different terms. A term is simply a section of a polynomial that is separated by operators from the rest of the polynomial. Our standard operators are addition, subtraction, multiplication, and division. In this case, we have separations based on subtraction, addition, and that's all. So our terms are 5xy squared, negative 3x, positive 5y, and negative 3. You'll notice I included the positives and negatives, or plus and minus signs, as part of my term. We want to remember that the operator tells us the power, or the direction of the term. So minus 3x really means negative 3x. Next up, we'll look at exponents. While every value in this polynomial has an exponent of 1, only the y squared has an exponent greater than 1. So that's really the only exponent we're going to be interested in for this problem. Next up, let's talk about coefficients. Coefficients are the values or numbers that are multiplied against a variable. In this case, our coefficients are positive 5, negative 3, positive 5, and that's all. Notice that the negative 3 at the end is not a coefficient because it's not being multiplied by a variable. Instead, that final negative 3 is actually a constant. Any numerical value that's not multiplied by a variable is a constant. This means that the value will never change regardless of what the value of x or y or any other variable is. In this case, even if the value of x was 12, the value of our constant, negative 3, stays the same. No matter what happens to the variables, the constant will always be the same. And finally, we can simply examine our variables themselves. Again, variables are simply letters that represent values that we don't yet know. So in this case, we have the variables x and the variables y. Let's talk about some special polynomials. There are 4 named polynomials that we'll be worried about. First is the monomial. Secondly, we have a binomial, then a trinomial, and finally an actual polynomial. These come from Greek roots, where mon means 1, so a monomial only has one term, such as 4x squared. Binomial comes from the Greek bi, which gives us 2 terms. For example, 4x squared plus 3. Tri means 3, so what we're really looking at is something with 3 terms. For example, 4x squared plus 3x minus 2. Finally, we're interested in polynomials. Poly is simply a term that means many, or in this case, we're talking about 4 or more terms. So for example, 4x squared plus 3x minus 2 plus 3y. That would be considered a polynomial. Now we're going to talk about like terms. The notes define like terms as a term where the variable and its exponent is the same. For example, the variable x along with the term 3x are like terms because the variables are the same as well as the exponent. In this case, they're both exponents of 1. So let's look at how some of these monomials in our 4x3 grid become like terms. Let's start with 7x. Our variable is x and it's raised to the power of 1. If we look through our choices, we'll also notice that 3x has the variable x raised to the power of 1, and the simple variable x is again the variable x raised to the power of 1. You'll notice that it doesn't matter what the coefficients are, in this case 7, 3, and 1, but only the variable and its exponents. xy matches up with 12xy, x squared y matches 4x squared y, 2x squared matches 6x squared, and the value of 3 matches the value of 4. This is because while they don't have a variable, they both don't have variables. Not having a variable is the same thing as having matching variables with the same exponents. It simply means that they can be combined. You'll notice that 5xy squared does not have any like terms because there is not another xy squared variable set anywhere in our grid. Now we'll talk about simplifying. The notes indicate that simplifying just means to combine like terms until only one of each term exists. So, example time. If we look at this expression, 3x plus 5 minus 6x plus 2, we can identify like terms. 3x and negative 6x, along with 5 and positive 2. When we combine our like terms, as such, we discover that 3x minus 6x gives us negative 3x, and 5 plus 2 gives us positive 7. So this problem simplifies to negative 3x plus 7. This next problem adds a level of difficulty. We start out with 4 parentheses x plus 3 end parentheses minus 2x plus 4. The first thing we'll have to do is distribute this 4. As a result, we'll get 4x plus 12 minus 2x plus 4. Identifying our like terms matches 4x with negative 2x and positive 12 with positive 4. When we combine them together, 4x minus 2x gives us 2x, and 12 plus 4 gives us 16. Finally, in the third example, we're simply looking again to combine like terms. In this case, 3x squared y and negative 4x squared y are like terms. You'll notice that 2xy and negative 2 don't match anything else, so they'll simply move on to their final problem. 3xy squared minus 4xy squared will give us negative 1x squared y. We bring down our 2xy and our minus 2, and we have a final answer. Remember that the negative 1 on the x squared y doesn't have to be written down, and we could simply have negative x squared y.